All right, so we're going to continue the discussion here with integration by parts. Looking at the next situation, we have the integral of x squared times e to the x dx. And so if we go back to our acronym LI8, remember that L is your logarithm, inverse trig, algebra, trig, exponential. We have two functions here. We have x squared and we have e to the x. This is a algebra part and this is an exponential part. Algebra comes before exponential, which means x squared is the u value, which means the rest of this is v prime. So e to the x dx is v prime. All right, so u prime is 2x dx, and v is e to the x. Substituting into our formula, which is u times v, that will give us x squared e to the x minus the integral of v du, or v u prime. That is going to give us 2x e to the x dx. And the 2, I can bring that out in front of our integral, which gives us this right here. All right, so if you'll notice, we have another situation here where it is going to require doing integration by parts again. All right, so coming back to here, we need to identify u prime, v, and v prime. All right, so u is going to be the algebra part once again. That is x. Its derivative is dx. V prime is the e to the x dx part. Its antiderivative is e to the x. All right, so copying down the first part, x squared e to the x minus 2. And now we evaluate this integral using our formula once again, which is u times v. So x times e to the x minus the integral of v u prime. All right, so let's take care of this now. We have x squared e to the x minus 2x e to the x. That's distributing. The negative 2 distributes to here to make it plus 2 times the integral of this. Well, the integral of e to the x dx is e to the x. And then we have our plus c on the end. So now you can see it took us doing integration by parts twice in order to get this down to where there's no more integral. All right, so let's try this another time here. Using your LI8, algebra comes before trig. So the algebra part is x squared. The trig part is your v prime cosine x dx. U prime is 2x dx. V is going to be the antiderivative, so that is sine x. All right, using the formula, u times v, that gives us x squared sine x minus the integral of v times u prime. So that's going to be 2x sine x dx. All right, so you're going to notice we have x sine x, which means we're going to have to use integration by parts again. The u is going to be the algebra part. U prime, therefore, is dx. V prime is the trig part, so sine x dx, which means v is the antiderivative or negative cosine x. All right, so substituting in our formula, we have u times v, so that's going to give us negative negative x cosine x minus the integral of v u prime. Well, v is a negative number, so this will change to a plus cosine x dx. All right, so let's rewrite the first part. X squared sine x, nothing happens there. Negative 2 times negative x, that becomes plus 2x cosine x. Distribute the negative 2 to this integral. It becomes minus 2 times the integral of cosine x, which is sine x. And then we have plus c tacked on the end. All right, so the next situation you're going to run across is sometimes repeated integration by parts does not appear to work. And so let's take a look at what happens here. All right, so the trig part here comes before exponential. Exponential is always last. So sine is going to be the u value, which means v prime is e to the x dx. All right, u prime will be the derivative of sine, which is cosine x dx, and v is the antiderivative, which is e to the x. All right, so plugging into our formula will give us u times v, so e to the x times sine x minus the integral of v du. All right, so what you should notice is that this is very similar to what we started with, so we're going to need to do the integration by parts one more time. Your u value will be the cosine, which means u prime is negative sine. V prime is e to the x dx, and its antiderivative is e to the x. All right, so substituting in, what that's going to give us then is we have e to the x sine x to start with, minus, and then we run our formula one more time, e to the x cosine x, that's the u times v, minus the integral of v du, or u prime. And the u prime has a negative on it, so this is going to change to plus, and then throw in the sine x dx part here. All right, so distributing the negative will give us minus e to the x cosine x minus the integral of e to the x sine x dx. Now, what you should recognize here is that we have an integral of e to the x sine x that we need to evaluate, which would involve having to do integration by parts once again. However, if you'll notice, that's actually what we started with. And so if we do integration by parts again, it's just going to put us into an endless loop here of doing the same thing over and over again. So what we can do to eliminate that is remember that this right here is equal to this. Remember, this is equal to, and then the integration by parts was this stuff right here. So this is equal to the integral of e to the x sine x dx. Now, what that allows us to do is treat this as an equation where we can add this integral over to this side of the equation. And these integrals are the same integral. So if we add this integral over here, what it's going to give us is 2 times the integral of e to the x sine x dx is equal to this. And see, what we are trying to do is figure out what is this equal to. Well, we can solve that by dividing 2 over to the other side of our equation, which means the integral is equal to this right here, except let me remember to put our plus c on the end. Alright, so using our acronym LIATE, the trig part is going to be the u value, so we're going to have sine squared dx, and then v prime is going to be dx, and that will give us u prime is equal to 2 sine x cosine x dx, and this is equal to x. So alright, so plugging in is going to give us x sine squared x minus the integral of x sine 2x dx, because that is what this trig identity is, equal to sine 2x. Alright, so doing integration by parts again, we have u prime, v prime, where u is x this time, and its derivative is dx. This will be sine 2x dx, whose antiderivative is negative 1/2 cosine 2x. Alright, so substituting in, we get x sine squared x minus negative 1/2 x cosine 2x plus 1/2 integral cosine 2x dx, and then we can distribute, giving us x sine squared x plus x over 2 cosine 2x minus 1/4 sine 2x plus c, and that is our final answer.